Hello, welcome to the presentation of Technology of Formula 1 Engine and Engine Control Unit Video Part 2. Presentation Overview. Previous presentation overview: ECUs, what ECU control, engine management, other ECU functions, data acquisition or telemetry, ECUs, ATLAC, Formula 1 engines, facts and figures. This is what we discussed in our previous presentation of Formula 1 engines. Introduction to development mode engines, Formula 1 cars and Formula 1 engines, how is Ferrari developed the engine, how ECUs came to scene, ECUs and what is it, ATLAS server or Advanced Telemetry Link Analysis System. First of all, we like to present you that how the Formula 1 era begins. definition of ECUs. The McLaren Electronics ECU is onboard hardware device with embedded code that gathers data from the Formula One car's engine, transmission, suspension system, frame components and other key elements, encrypts the data and transmit it to the trackside support team. What ECU control? Engine management. The 800 bhp of a modern F1 engine is largely a result of a complex electronic control unit, or we can say ECU, that controls the many systems inside an engine so that they work to their maximum at every point around the lap. Engine mapping can change completely from circuit to circuit depending upon the nature of the track. At Monaco, for instance, the engine control system will help the driver have more control on the throttle input by making the first half of the pedal movement very sensitive and the latter half less sensitive. This means the driver can have great control on the throttle for twisty corners, so that it is easier to limit the acceleration out of corners so not to spin the wheels. At somewhere like Hockeymonds, the driver has to jump on the throttle more out of the chains rather than gradually applying full throttle. The accelerator will be set so that only a small movement will result in full engine acceleration. It is also positive to gain out any unpedaled movements of the throttle, such as when a driver travels over a bump and his foot may move slightly. The engine control system can cut out the jumps of the throttle and keep full engine down the straight, even the bumpy tracks. This is all possible because there is no direct link between the engine and the accelerator. The accelerator position is sensed using an actuator, and the signal is then sent to the engine control system, from where it is passed on to the engine. The engine ECU is much more than a device for making the throttle more or less sensitive. The ECU controls the inter-thumb height, fuel injection, among other things, to try to get the maximum torque out of the engine in the modern world of electronics. The ECU monitors many of the engine parameters, including RPM, to control the torque output from the engine. This means that the modern day F1 accelerator acts more like a torque switch than a simple pure input counter. F1 engines are so complex that they are designed to run in a small power band between 15,000 to 8,000 RPM, and the electronic monitoring and controlling of engine parameters are circuit in keeping the engine in the working region. This working region is where torque is virtually constant, and letting the engine get below the lower than would see the sudden drop out of the torque until the engine began to rev in the working region.